this water drop, we'll be taking a look at RTC for ICM, real-time controls in ICM to be able to take control of pumps, gates, and other objects within ICM. So who's this for? Really just engineers that are interested in how real-time controls and the applications for them in ICM, and modelers interested in some of the basic setup and inputs for RTCs in ICM. The workflow is pretty straightforward. First, you set up a simple logic for an RTC on a pump, have it turned on and off, run the model and check results, modify a couple things, see how that impacts the results. We'll also set up an RTC for a variable speed pump, run the model subsequently, and check the results as well. We'll also take a brief look at an additional 5 RTCs and some of the examples in the help menu to be able to get folks started, and then also look at a dam break example using variable geometry as the RTC control. So we have here just a simple network where we've got a pipe here. I've got this inflow file here that I'm going to be using in the run. It's just a static flow there. But it's entering the node up here at the top, flowing through here into a storage well, and then ultimately out through the pump here and out to an outfall. The pump here, you can see it is a fixed pump, but with the RTCs we're going to override that and be able to control it with the RTCs. So there's really 3 major parts of the RTC, and they all start with R. The regulator is the first thing. So this is essentially the thing that we're wanting to control. In this case, it's the fixed pump downstream, and the suffix link is 1, so we've got the .1 there. So I press OK. The second piece is going to be the dependent objects in here, where the first one is going to be a set of ranges, and then after we get in those ranges, we'll have rules to be able to define the action when the range is true or false. So the range is more so telling the regulator when to operate, and then the rule is the action that takes place once that range has been seen as true. So we add the range in there. We're just going to name this cut in. So this is going to be the in this case, we're going to set the height above the datum. So this is the elevation that it's going to cut in at. And for a minimum value, I put 7. For a maximum value, I just leave that blank to have it stay as, gotta select my node as well, update there. So this is essentially saying that the pump is going to cut in once that minimum value is above 7 feet. I'm going to go ahead and enter another range for when I want the pump to cut off. Name that cut out, and then the height above the datum again, and then the maximum value there is going to be 5. So I'm going to hit update there, and so basically whenever the pump or whenever the elevation in the node of the wet well reaches 5 feet, it's going to cut that off. So next thing we need to do is add in the rules associated with this. The first one is going to be for the cut in, and this is just going to be that it's turned on. So we get that switched on, and then we can go ahead and add in the second rule, which will be for turning off the pump. So with this, good steps are you can validate it just to kind of get an idea of what's going on, gives you any kind of errors that pop up, and then also gives you this nice description. That description also comes if you just highlight on the regulator that you have, and gives you a nice kind of spelled out method of what you're going to do. And it's good for just kind of a check to make sure that everything is kind of populated in the right space. So I'm going to go ahead and close that tab, and then commit the data to the database. I'm going to say added simple RTC. Hit OK. Validate all these scenarios that are in here. We really just need that one. I'm going to open up my run that I've kind of already created. So I've got everything set up in here already for us. I've updated the network there, and then going to hit run it on this computer. Pull up the job progress window just to see how things are going, but it shouldn't take more than just a few seconds here. So we can open this run up. I'm going to close down some of these just so we can get a better view. And then also start to look at some of the results. I can look at the flow in the pump. We can say looks like that's bouncing back and forth between the that value 2. I can also look at the level that's in my wet well. So you can see that it's kind of shutting off once we get up to certain elevations, trying to maintain it between 5 feet and 6 feet. Part of the reasoning behind the kind of choppiness of everything is the runtime information that we have set up in here. So if we notice back in our run, the time step for this is 60 seconds. If we change this to 5 seconds, we'll actually get a much more discretized look at everything. So again, just waiting for that run to complete here. Again, shouldn't take more than a few seconds. There we go. And if we go and look at the flow in here now, get a lot more on and off essentially. We can also look at the status. It's going to look pretty similar to that, but because the time step is now much lower, the reaction of the pump is a lot more. So if we look at the level, we get a little better kind of performance. If you remember before, some of those peaks were around 7.5 feet. Same thing with the bottom, and now that we've shortened that time step, we have much closer to those values of 7 and 5 that we put in there in the first place. All right, so back at our network here, we're going to move on to creating that variable speed pump RTC. I'm just going to use the network that we have as the basis for there, but first things first, we need to come into the pump and then switch it to the variable speed pump. I'm going to set the maximum flow just to something a little more reasonable, and then also the rate of change in there, even though that's going to be overridden in our RTCs. So this is the old one. I'm just going to go ahead and remove this, delete it out, since we no longer need it. First things that we're going to do is to add in the regulator. So again, what we're controlling, these values over here do need to be estimated. So initial pumping threshold can be 0, and then those rates of changes, like I mentioned. So I'm going to put into here just 0.2, pretty reasonable value. So after that, then we start to build in the ranges and rules. First range in here is going to be essentially setting the level that we want the wet well to stay at. This will be dependent on that node, the wet well, and then we're going to say we want it around 12 feet as the minimum, and then add in another range to give us the other side of that, and we're going to say level down. Node and then 12. So essentially what we're trying to do is just maintain the elevation to be that value. Next thing we're going to do is come into here and add a controller. So the controller is essentially going to tell us how the action should take place. I think it's the best way to consider that. Just going to call it control 1. There's a couple of different options in here. Probably one of the more simple ones would just be the incremental, and then saying how often that increment should be. So we're going to do it every 60 seconds in this case. Lastly, for this step at least, we're going to add in those rules, level up. This is going to be based on that control 1, and then this is going to be the basically rate of change We're then going to add another rule for being able to wind down the condition here. So level down, control again, control, and then this is going to be a negative 0.01 for decreasing it by that amount. So we can see, so the next step would be to give a definition for when the pump needs to turn on. So I'm going to make this pump on, and still dependent on the datum and the elevation of the wet well. These are going to be the same that we had in there before. Since they are below the threshold, what will end up happening is that the pump is just going to try to maintain that 12 feet. It's always going to be on, but it'll be decreasing and increasing through that period. So I'm going to say pump off, and again on the wet well, and maximum value of 5. So we're going to insert the rules now associated with that. So pump on is going to make it on, and then pump off will make it off. We have all that squared away. I'm going to come up here and then commit things, VSP, RTC, hit OK there, validate everything, and everything's good to go. I'm going to come back over here, go to my run, make sure I'm updating to the latest here, and then selecting that RTC. So run the simulation. Once that's finished, we're going to go ahead and open up the results and look at some of those results that we had before here. So looking at the flow, pretty similar to what we had before. Also going to look at the level just to see how good things are responding. So if you remember, we were trying to maintain that level as 12. You can see that that response is kind of sluggish in here. So we are kind of bouncing around a good bit. Somewhat similar to that time step, we have an issue with the RTC that's really causing that. If you remember in the controller, that was every 60 seconds. If we decrease it to something a little more to something a little more frequent, we could also modify these level up, level down, incremental changes here to something a little higher to make that modification go a little bit quicker. So I'm going to come in here and then commit the data to the database, just say update RTCs, successfully validate everything, come back into my run here, update to the latest, and then rerun that simulation. So once that finishes up, we can go ahead and look at the results and go back to look at that level in here and see if we get a better response, and of course we do, maintaining that level of 12 much better than what we were doing before. Lastly, we're going to take a look at some of the other RTCs that can be put in here. We've got a couple for tables or variables. I'm not going to go into detail about these, but these can just be different use cases for controlling gates or sluices or whatever else in here as well. Doing some of the more incremental controller types of stuff, as well as using tables in here. A lot of this can be found on the help page, so there are some examples that you can kind of walk through yourself, be able to put those together, get a little better understanding of things. The last thing that I wanted to highlight was the project doing a dam break analyses with RTCs. I'm going to open this up and just give you an idea of what this looks like. Change this to make it a little more visible. If I come into here, you can see the section elevation. The base linear structure here has on the right side this RTC definition to it. It's blank in that one because we're at the base. I'm going to switch it over to the breach with RTC though now, so we can see that RTC definition, just 1, 2, 3, 4, 5. Those all relate to geometry varying points in here. So this was a little bit of a time-consuming process because each one of those points is correlated to a vertice that's on there. Just to give you a better kind of breakdown of all the points in there. The RTCs in here, as you can see, are varying with time, and the elevations associated with those are varying there as well. Just wrapping things up here. This is that dam break there over on the right side. But like I mentioned, there are RTC examples in the help menu. So just search for RTC examples. Of course, our great support team is there to support you if you do get stuck on anything. And surely don't be afraid to try out things. There are the validation, undo, and helps there to be able to help you with things. And really just the last piece of advice, just be very clear about what you expect to happen and to use the graph tools and just review the results to make sure what you think is going to happen actually does happen.